Mid-terrace dwellings are easily designed using the four-side system, but this dwelling is more challenging because we have added a flat roof extension with a parapet. You input the details of the project. We will use the partial fill method of construction. It is attached with a flat roof and parapet, and the insulation is below the floor slab. Usually dwellings like this have timber joists. ACDs are no longer sufficient. If the new fee standard is to be achieved, we need to use the robust or enhanced detail. The project has a pitched roof and the insulation between and over the joists, so this option should be taken. It is mid-terraced and the dwelling has not got a basement and is not an apartment, so therefore all other dwellings is chosen. As you can see, there are a lot of construction joints with this type of dwelling. The extension means that there are more exposed areas than a normal mid-terrace building. The exposed wall on roof areas and construction details makes design compliance difficult to achieve. We have more construction details. This project has 3 exposed elevations and there is a small volume with these dwellings. Compliance is also made difficult by contemporary design, which has a lot of glass, and this can cause overheating. We have collected the dimensions required by SAP and the thermal bridge calculator. Now let's design the part L1A specification. Before we start into the design process, let us look at the thermal bridge. As you can see, it is over 0.1, even though we have used enhanced details. This is because of the length of the construction joints and the exposed areas with mid-floor dwellings. The recommended Y factor is 0.05 when designing to the 2013 regulations. Now let's go back to the first part of the specification to be designed, the ground floor. When designing a part L1A specification using the four-side system, the user chooses a performance level to design to, in this case the 2013 regulations. The designer chooses the structural materials, insulation materials, and the software works out the recommended depth of insulation. The U value is calculated to be R433 and is used by SAP to calculate the performance of the dwelling. The wall. The 2013 standard is chosen. The four-side system understands that the Y factor is not good and it will increase the performance of the insulation to compensate for this. For the flat ceiling design, the 2013 option is taken. The user chooses the centres of the joists, the insulation between and over the joists, and the U value is calculated. The sloping ceiling does not need to be designed. The areas not to be designed are locked and the designer simply clicks on save and is automatically taken to the next section to be designed. There is a flat roof that needs to be designed, so we choose the performance, centres and insulation material and click on save. The windows. The designer chooses the 2013 standard. 2 choices will be presented. The designer should choose the 1.4 U value for the windows with the mid-terrace design. With the door, 1 U value should be taken. Roof lights do not need to be designed on this particular project. Thermal bridge is very high and this has been discussed earlier. Air permeability. The user chooses the 2013 standard and the software will give 2 options. It is our advice that the designer chooses the 5 air exchanges. Anything less than 4 air exchanges will require a heat recovery system. Heat recovery systems suitable for small dwellings are not common, and this is why mid-terraced dwellings should not be designed to an extreme fabric standard. This is something the industry needs to look at. With the air tightness chosen, we can use natural ventilation. Lighting should always be 100% energy efficient. Stoves as a secondary heating source can be considered if the dwelling is non-compliant with the DER, but for the initial design, a none option should be taken. For solar panels, a none option should be taken for the initial design, but it can also be considered if the dwelling is non-compliant with the DER. Hot water storage. If a boiler other than a combination boiler is used, the software can design a hot water storage tank most suited to the project being designed. The user inputs the number of occupants if solar panels are being used, and the software calculates the size in litres. The depth of the factory insulation is determined by the performance level chosen and is used in the SAP calculation. Water usage. Reduction in the water usage helps with the code for sustainable homes. Boilers. All our boilers have an efficiency of 90%, and we are using a gas condensing boiler. Heat control is now becoming a very important part of Part L1A design, and we're using the delayed start thermostat and programmer and TVR. All the design decisions have been made. Now let's see if it is compliant with the 2013 regulations. As you can see, the DFE is very compliant, but the DER is non-compliant. So let's go back to the design process. The fabric is over compliant, so we need to increase the performance of the fixed building specification or introduce low carbon technologies. We've used in this design the most efficient boiler and heating control systems that are readily available, so we need to introduce a secondary heating source such as solar. So we choose the 2013 standard, the pitch of the roof, the number of occupants and orientation, and the type of panel, and the software will work out the area. So we click on save. We also need to redesign the hot water tank. So we need to include a solar panel in the tank, and we click on save. Now let's see what the result is. We now have compliance with DER. From our experience, the fee standard is as high a performance that can be achieved with mid-terraced design, and with the technology that is in common use at the moment, extreme fabric with low air exchanges cannot be achieved because of heat recovery systems not being suitable.